Where we're at is actually the Cowichan Lake Research Center, and we're social distancing. But these plots were established in 1929. The Cowichan Lake Research Center since 1930-29 was a major focus of research in forests and about forests in BC for many, many years, until 20 years ago when essentially got turned into a backwater, and it's not utilized that much anymore, which is a crying shame in the face of climate change and pandemics. Like, we need good data about these forests. So here's some plots here that were put in 1929 after they did some logging in here, and there was a fire, burned again in 1909. But we need this good long-term data, and in here they've been measuring downed logs, coarse woody debris, and how they've been changing through over the last century. And we're almost coming up on the anniversary of that too, pretty well, here in a few years. So we need this important data, and here's a nice little hidden ecological gem out here that we need to be measuring and researching more. A paper came out about 10 years ago, but there's all kinds of places, plots that need to be rediscovered around the province that will tell a story of how these forests have changed, or the potential of these forests going forward in the 21st century. And we need to rediscover these scientific roots that are hidden and forgotten all over the place, that we need to bring to the current time, digitize them, collect some data from them, and start asking questions that we can look through long-term change over the last 160 years or so. This is a cool stump from probably maybe the turn of the century, 1920s, maybe even earlier, 1800s. So these notches you can see here is where the guy stood on what are called springboards, which used to be 6-foot long boards, and they would stand on them to cut down the trees. But you can see they've gone up here 2 levels and stood at the higher level to cut the tree way up on top. This is just a small example of how big the trees used to be way back when. This is a small, big one.
Yeah.
But you can also see right now it's extra habitat too, because there's a hemlock growing on top of it. Lots of times you'll see huckleberry plants growing on top of them, or other big seedlings, Douglas firs and cedars grow on the top of these stumps. But also, I think in second growth forests, big stumps like this are going to be the carbon source going forward, because in our current harvesting, we harvest them so early that the stumps are really small and don't get as big as what they used to be in the old growth days. So this cut stump and its big network of roots, what would have been the roots under the ground, is a huge carbon pool that nobody measures in ecological science anywhere. But this is super, super important, is when you need to have the big, huge, large live trees, you need to have big dead standing trees or snags, and then you need to have downed logs, because they're all part of the cycle of recycling energy, recycling carbon, making soil. This big log will eventually rot away over hundreds of years, but for as many years as these trees are standing alive, their dead cycle will be an equal amount of time. So if this tree is 500 years old, well, its dead cycle will last another 500 years. And we need more logs like this on the ground to stop flooding like we have in the Cowichan Valley, because we need to let these forests up in the hillsides be super water sponges, so the water stays on the land, in the soil, into the aquifers, and into the wetlands, and isn't running down the hill and trying to flood out the flatlands. In our harvesting systems, we take all the logs away and we leave the smallest branches essentially on those sites. But even now, people are trying to collect all those up for bioenergy too. That's going to decrease soil production, moisture holding capacity, and make the forest even drier than it already is. So fires have been used by First Nations, and we, for 100 years in our colonial system, have been putting out forest fires that are important as an ecological process, but we've out there protecting timber values and houses and home, which are important. But in a lot of cases, we've stopped those natural fire cycles, which have changed the productivity of our ecosystems in just a short 100 years. So I think this here, and it doesn't quite look, I'm expecting more sort of a funnel cake, but I think this might be velvet top fungus. and its at home Latin name is Phaeolia schweinitzii, if that's what it is. But also huge driver in Douglas fir ecosystems. That fungi are a big driver that turn live trees into dead trees, dead standing, and then eventually down logs. So these fungi are hugely important. So for every footstep you're doing in the forest, there's 300 miles of fungal networks underneath each of your footsteps that are connecting. So the mother trees are doing the photosynthesis. They're the big power plants. They're bringing down moisture and they're sharing it. And they know that they share it with their own seedlings. They can identify their own seedlings from the mother tree. And so they're making sure that they're connected to the mother tree and passing on nutrients to them and making sure that they survive as opposed to other seedlings. So these fungi and these connections, these interconnections between plants and animals and species and water and ecosystems and the land and the soil, how this has all been spinning for the last 10,000 years. We've come in and disrupted it in a major way. This is a live stump. This stump is still alive. So by definition, if you cut a tree down, you'll see a flat top and you'll see the growth rings, but we don't see that here. We almost see like a scab on top. So this stump is still alive, being kept alive by this tree and that tree because of the fungal network that is connecting, that where they were formerly connected. The tree that was here, its roots were connected to all these here, these two trees, and they're still connected. So after the tree was cut down, these trees, and actually they've done measurements is where the trees that are around here will bump up their photosynthesis to supply this. But this tree here, this is a Western yew. But in the 1980s, all of the Western yew in BC, Washington, Oregon, and California were almost killed completely because what they had discovered is that by taking the bark of the yew trees, you could make an anti-cancer drug called Taxol. Because the genus of this is called Taxus. Taxus brevifolia is the scientific name for Western yew. So they knew that they had, by taking the bark, and so they harvested too much of the bark, but they were going to wipe out all of the Western yew trees to make this drug called Taxol, and which was good in one sense, but what happened is that they were going to all disappear. So luckily, the scientists were able to synthesize Taxol, and then that saved the Western yews. Then they stopped harvesting the bark from them, but of course they over harvested them, right? That was the thing, is that they were going to wipe the Western yews out completely. And these trees take hundreds of years to get the right conditions for them to come in. They like moist conditions, they like shadier, cooler, old growth conditions. And so again, after a forest fire or after logging, the conditions may not be right for several hundred years for Western yews to come in, let alone fungi, let alone northern goshawk or marbled murrelets, all these kind of plants and animals that need lots of time for those ecosystems to recover after windstorms, after forest fires, after logging. So this is kind of neat here too, that this is a Douglas fir and a red cedar that are growing together. And in a lot of cases in the forest, the cedar and the Douglas fir cedar will grow with hemlocks, they'll grow with Sitka spruce, they grow quite happily close by each other, but not a lot of trees or the Douglas fir don't really like a lot of trees growing with them. They will happen, but sort of true trees, sort of similar age, similar start time, that kind of thing. So they're very happy to live together symbiotically out of the same microsite. Size doesn't always equal age or more age. Most of the time it does, but it depends on the conditions, depends on the tree species, whether a small tree can be an old tree too. So it just depends how did this ecosystem come together and change through time.
Right.
And those are key ecosystem decoding questions of how did this forest get to be the way it is? When was the last time a fire went through? When did it get logged? And then if it got logged, how did it get logged? Were they leaving more trees at that time? And all these different, there's tons and tons of variables that nobody just thinks about, is that, we'll just go cut it down, plant, and away we go. But real forestry is about going in and manipulating forests, like tree heights and tree densities and tree species. That's what forestry is, not, grow, cut, grow, cut, grow, cut, grow, cut, right?
Yes.
Right? We've gone away from what forestry is, too.
Yeah.
Yeah. So then also what I would suggest too about the Yubo hillside too is that Yubo hillside is about 80 to 100 years old too. So it's on that cusp of starting to develop old growth characteristics, late successional forests. The trees are bigger and older. And this is some of the stuff that we have to be letting these forests do, that the longer we let them grow, they're going to keep doing those ecological goods and creating those ecological goods and services for us. And those ecological processes will have had a lot of time to recover, because when you do logging and burning, well, all those kind of ecological processes are broken, disrupted, and it takes a long time for those processes to come back and to be rejuvenated. And as well, the forest conditions in here too, like there could be moss, there could be lichen, there could be salamanders that are looking for some of the conditions that we had at the bottom of the tree, the bigger, older growth, shadier, cooler, moister forests. So those conditions may take 100 or 200 years to develop after a fire or after logging or whatever the case may be, whatever the disturbance was. So this is really neat here too. This is a neat section in here too that has a lot of mosses going here too. We've got electrified cattails going here. I think there's steppe moss over here. But in this one spot here, there could be literally 20, 30, 40 different kind of mosses here. And lots of times mosses and lichens grow together. There's moss mats up in the tops of maple trees. And the moss mats are collecting moisture and nutrients. So the maple trees way up in the top of the trees put out roots into those moss mats to collect moisture and nutrients in a soil layer that's no different than the soil down here. And roots no different than down here. Amazing. But these moss mats too, this is on the forest floor here, are your water sponges, your flood preventers, along with the big rotting logs on the ground. Yeah, so this is electrified cattail because it literally looks like electrified cat's tail. And steppe moss over here, and many other ones. There could be a palm tree moss down. I think there's palm tree moss down there as well. Rotting logs, mosses and lichens, and forest cover, big forest canopy, tall trees, lots of layers, lots of branches, lots of needles, all slow water down at every step of the way. And that's what we need to do, is let these forests be the natural water sponges that they are, and let them do that job, and work with wetlands, which do watering and filtering and storage of carbon too, and slowing water down, and even logs and streams that dam up the water too, slow it down, create pools and riffles so that there's habitat for salmon. All of those together slow water down every step of the way. We're slowing water down every millimeter. Clear cutting just lets water run wild and blow out culverts and roads and put sediment into streams. So natural forests, if we let even plantation forests grow old, these conditions will develop over the next 100 and 200 years, and let them be the big water sponge systems that they are. And maybe even more important than carbon storage, but probably not. But another huge ecological good and services that these forest ecosystems provide. So this is a really, really great mature and now second growth, because we can see the stumps over here that they were logging here in 1899. So this is kind of some of the ecosystem decoding that I talk about, because this tree, based on its size right now, and if they logged 100 years ago, 120 years ago now, this tree, I believe, is, if it isn't just 120 or it's slightly older, this tree was accidentally left when they were logging here. It didn't get clear cut, it didn't get cut down, because they were only chasing the trees they really wanted to cut down, which means that they accidentally retained this tree for it to be here for us today. And that's part of a whole thing of ecological forest management that we've learned from Mount St. Helens and other places, of these biological legacies. So this, as a biological legacy, got left when the disturbance that went through here, which was logging in this case, it got left here. And Mount St. Helens too, they found all kinds of dead trees and logs that were on the ground that get forwarded to the next ecosystem. So since this didn't get cut because it wasn't merchantable for them, or it was a seedling or a sapling or whatever, however it existed then, it was allowed to keep growing here. And as a result, today we've got this huge, beautiful, mature, second growth, essentially, Douglas fir tree. And that's what ecological forest management is about, is like leaving leaving the important bits or making sure there's a representative. We have seedlings, we have saplings, we got pole size, we've got intermediate height, co-dominant and dominant trees. We have multiple tree heights in our forest, and that's what ecological forest management tries to do, is make sure that there's a representative sample there. What was the forest like before? We're going to keep those in our forest harvesting, making sure there's logs in the ground or dead trees. We're recruiting and retaining all those important elements of a forest. This was retained accidentally, but as a result of that, we have this beautiful, big, huge tree. This is really neat in here. If you can see even behind me, we got little logs, or not little logs, big logs down in here. This is a little ephemeral stream, a little wetland. We got salmonberry in here. We've got alder. So this is a little wet ecosystem. We can see all the grasses around here, all the ferns. So this is a teeny weeny important wetland that is sponging up water too in the wintertime and slowing it down. And these small wetlands in headwater areas and everywhere, but in particular headwater areas in the tops of the mountains that are small wetlands, 1.5 meters long, 30 centimeters wide, and 30 centimeters deep, control stream water temperatures all the way down to the ocean. So if we're not protecting those little teeny weeny wetlands that also are storing carbon and filtering water and all that kind of thing, then we're making it that we're creating lethal temperatures in the streams for our salmon, because if it's over 25 degrees Celsius, then that's lethal temperature. The water is too hot for the salmon and it can kill them. So small wetlands, little teeny weeny riverine systems are hugely important. And also you've got alder here. So there's enough water running through here. So there's water in here most of the year, unless not in summer. But so this alder too is what we call a pioneer species. It will come after a forest fire or after logging. It's putting nitrogen. It has nodules in its root that put nitrogen into the soil. And research a year ago showed that the bigger alder trees are going down to bedrock, smashing apart bedrock and bringing minerals to the surface and putting it into the soil.
Oh, so Roundup then?
Yeah, so Roundup is hosing down cottonwood trees, alder trees, all these beneficial trees that there's species that are dependent on these broadland species like maple trees, and we're trying to nuke them in the interior. Poplar trees, aspen trees are on these trees too, and cottonwoods we have on the coast absorb moisture, so they're actually forest firefighters, right? So we for probably the last 40-50 years have been trying to kill all the broadleaves because they've been getting in the way of the conifers, but they do all kinds of valuable jobs. They also drop their leaves, so these leaves are full of nitrogen, and that's putting nutrients back into the ecosystem. So this is a really interesting part of this forest here. Way behind me here is part of a wetland connection from this area that we passed just back there where I had the logs in the stream, but it's really, really beautiful below us. But here, these tall sword fern that are almost as tall as me is showing how rich and productive this piece of forest is. This is sword fern, and they indicate rich and moist soils and good growing conditions for the forest in here. And we get places in wetland areas. We get great big skunk cabbages that are 3 feet long. But look at this. This is almost 5 foot tall sword fern here. So this is showing how productive these ecosystems have in BC. And we in BC and on the coast here and on Vancouver Island have some of the best forest growing ground there is in the world to grow the biggest and oldest trees. We've come out of the forest and we're now in the open. It was nice and cool and shady in the forest, and even, I would say, moist. Yeah. But out here, that forest cover is gone from over above us, so now we're exposed to the winds, we're exposed to the direct sunlight now, and we notice the change in the temperature. So that's what forests and trees do, is that they cool the planet. They shade it and cool it, and by actually sweating through their needles, they're putting moisture into the air and cooling the planet down. That's what they do in a lot of cases, shading and cooling the planet on top of storing carbon, filtering water, and those types of things. So when we come into these open areas, in particular clear cuts, we end up having lots of slash accumulation. So it's a sea of slash. There's a raven up there. But we have a sea of slash that then becomes a fire hazard because it's the smallest pieces, which although they get wet in the wintertime, they dry out very quickly, and then in the spring and into summer, become high fire hazards. And that fire hazard from fresh slash can last, in a medium to high point, can last for 40 years after logging. So when they've logged an area and left slash, that can be a fire hazard 40 years into the future, which is crazy. Another thing is when you take away all the forest, then invasive species like to come in and take over. And we got lots of grasses around here, but also here's broom, and broom loves wide open, hot, sunny spaces. And broom by itself is a fire hazard too. So in a lot of places on the coast here, when you see a clear cut, you're going to see tons and tons of broom if they aren't out there looking after it. One of the remedies for that is to make sure that your forest canopy, your forest cover stays intact, or as intact as possible. So one of the other points I wanted to make too is that about ecological forest management, it's going to be hard to do because it's really tricky leaving big, large live trees and dead trees standing and logs on the ground. It's way harder than it is to do clear cutting. Clear cutting is easy. But the really good point about it is that we're going to need all of the smarts of the loggers and forest engineers and foresters to figure out how we used to do things in the past using long line harvesting systems and going in with power saws and cutting trees down in a hard way, not the easy way. So actually, we're going to need all of the loggers helping us out to figure this out, to do it in a more ecological way. So I think there's going to be more employment, and we're going to need to utilize their brain power, because that's what it's going to take. They can actually get a better result on the ground for us than we can if we try to over-prescribe it on a piece of paper. We'll do that still, but they will get us a better result on the ground based on their forestry knowledge and logging knowledge. And we need that in order to go forward. So we need loggers to help us out with this. We don't need to alienate them. We don't need to exclude them or vilify them. So this is really interesting because you can actually see the planting lines where the planters went down and planted this maybe 65, 70 years ago kind of thing, maybe quite not that long. But you can see how manicured it is too. There's probably sort of 1,200, 1,400 stems per hectare here. But also this is a nice example of a second growth stand, which is now planted. They're all even aged. The tops of the trees here, everybody's at the same height. And it's completely different than the old growth forest we were in earlier, where there's multiple heights, multiple ages, densities changing backwards and forwards, small trees, bigger trees and shrubs, and then really tall trees and really big, large trees, large dead trees. But here we don't have any dead trees in here. We have very little in the way of decaying logs on the ground. And also the amount of light that's in here too. Like we have some moss growing here, but a lot of the other species that we saw growing there, the big sword ferns and salals and salmonberry and that have more light. That old growth forest has more light than this sort of second growth stand does. And this forest too, if we give it time, could develop in the next 50 to 100 years and longer, could develop into that old growth forest. But it's going to need fungi coming in, that we need trees to die, we need trees to fall down and be logs on the ground. And it's a very kind of a manicured way to do forestry, and how we've always done forestry. We started planting them in the 1940s because of the huge wildfires that we had going at that time. So I like trees that are back, that we have them here, but we have to also, and these trees now that they're in the age now, as they get older here, they're going to be doubling the cubic meters per hectare between age 60 and age 100. So they're on that cusp, just like the hillsides above Yubo are on that cusp of becoming old growth. If we let them grow older, they'll store more carbon, they'll start those processes, the fungi will come back, the fungal interconnections are developing now as we speak, but could take hundreds and hundreds of years to develop. Lichens sometimes could take 200 years to come in after a disturbance. So all of that takes time, and if we're cutting them every 25 or 40 to 60 years, we'll never get all of the possibilities, the characteristics, the structural elements, the ecological processes that old growth forest has. We won't get them if we cut this now, or we wait another 20 years or 10 years to cut this. They'll never make it to old growth and turn into super water sponges and carbon storers and water filtrators and habitat providers and shading and cooling the planet. So it's, we have such a great opportunity. Some people have said, and foresters who are friends of mine too, that we have some of the best tree growing ground in the world, and we just have to let it, we have to let us help it to help us. And it's crucially important that we need to look after these ecosystems, and we need to have a wide range of early sterile habitat like this cut area here where there's grasslands, there's browse possibilities. And songbirds use those kind of areas, and there's browse for elk, there's browse for deer. But then we need slightly older forests, and then 100-year-old forests, and then 200-year-old forests, and 500 and 1,000-year-old forests. We need our landscapes full of all of those types of ecosystems and all their parts, the wetlands and the rivers and headwater streams and salmon habitat, and let these forests do the job that they do. They protect us from all kinds of things, and they give us all kinds of things. And by doing our regular sort of what we do as forestry, which is cut and export, we're losing out on this ecological bank account, these natural assets that we have. And there's tons of jobs. We're going to need loggers, we're going to need foresters to figure out how to do this better for the 21st century, to slow down and stop, if we possibly can, climate change. And our forested ecosystems are going to be our natural tool to help us do all of those things and look after our water and our watersheds and our health and our mental health and our cities